on surveying security practice adherence in software development.
Thank you.
I have the privilege of being the last speaker.
And I want to thank each one of you for sticking around to the bitter end. I'll try and be expeditious about the slides. So, surveying security practice adherence in software development. If you Google vulnerability logo, you'll find a series of them. You may recognize, for example, shell shock or heartbleed. These have become headaches for software development teams, as I've illustrated here. You don't want your mistake in code to become legendary, to have a brand. There's an old political writer who once said, when the going gets weird, the weird turn pro. And with vulnerabilities with brands, I think we're beginning to see that. So the good news is that there's a great deal of advice about what to do as you build software to prevent vulnerabilities. The bad news is there's a great deal of advice about what to do when you approach resolving vulnerabilities in software development and figuring out which practices are appropriate for your situation and how to choose them and which ones are suitable is a bit of a challenge. So the goal of my work was to try and establish a basis for describing these security practices, to try and find the core security practices at the heart of all these recommendations, and to develop some adherence measures for measuring them. So, 2 research questions: what software development security practices are used by software development teams? And then, does security practice adherence, as measured by 3 metrics, correlate with security practice use? So, if we can establish a basis for measuring these things, we can start to collect empirical data for a team to do a self-assessment, for a team to do assessment of itself over time, to evaluate a group of teams, to see how they're doing compared to each other, to build a global population of data to see what practices work in what situations. So methods for the what practices. Literature review of the 4 lists that we saw earlier. Rebuilding security in maturity model is one. The Microsoft security development lifecycle is another. A couple of more practice lists. And so we went manually through those lists and resolved them, which we'll give an example of in a bit. And then we took the practices that we established and then we surveyed 11 open source projects with them to see if they saw what we saw. So what practices? For each security-related action described in one of our source documents, we identified we developed a category of practices over time. We'll give a couple of examples in a minute. Identified the artifacts affected, for example, source code or test suite or bug report or so on. The artifact reference, perhaps there was a coding standard or a threat model involved. The verb, the role of the person applying it, was it a manager, was it a developer, was it a tester, was it an operator? And we identified the lifecycle phase during which the recommendation was given. Is this something for requirements? Is this something for operations? So here's an example. So we have a practice named Apply Secure Coding Standard. BSIM suggests that you use coding standards. SafeCode suggests, for example, avoid string concatenation for dynamic SQL statements. And inside the security development lifecycle documents, it says null out freed memory pointers in code. And the commonality that we see among these is that there's some standard for how code ought to be that the developer should apply as they go about their business. So we take the notion of a coding standard that's our artifact that is applied to source code, that is done by a developer, and this would typically happen during implementation. As a counterexample, something we excluded things, develop an operations inventory of applications. That's an important thing to do. Development teams don't always do that. It's usually done in the context of operations. So we were focused on practices for software development teams, and this is an example of the kind of practice that we did not include in our set. So this is an unreadable overview of the practices that we came up with. We came up with 16, organized by the sources from which they came. And different sources have different preferences. I don't know if I can get it. So for example, the BSIM tends to be focused more on things like security review, The Microsoft Security Development Lifecycle tends to have things about secure coding standards. Each one of these has gaps compared to the others. Each one of these has strengths compared to the others. But we sort of have a basis for comparing them in the form of these practices. Now, down at the bottom, there are some practices that are only mentioned a handful of times. Published disclosure policy, for example. We did not survey the bottom 3 practices because they appeared so few times and because we wanted to concentrate the attention to the degree that we could in the people that we surveyed. This is a different view where I have the practices laid out across the development lifecycle with the documents that are created as you go about applying those practices. For example, the threat model shows up early, and security requirements show up early, the secure coding standard applies a little later, and so on down the life cycle. Here's an example practice definition. There's a link at the bottom. If you Google me, PJ Morris, GitHub IO, or PJ Morris NCSU, there's a guidebook where we've listed the practices and given some detailed examples of things that show up. So at the high level, we have apply security coding standards, but there are some more specific questions. Like, for example, is logging required by the coding standard? Is cryptography addressed by the coding standard? Some more specific questions about implementing these things. And that's true for each of the practices. So we have a list that we think works. Does it work actually? How does our list compare with what development teams actually do? So we developed a survey instrument based on the practices and a series of questions about them, and sent them out to security-focused software development teams. Beginning with the team inside IBM, we shopped the questionnaire around within my research group and with the team I was working with, and we gave the survey to them. We had a 40% response rate, which we felt comfortable with. So we were a little bit surprised when we sent it out to our 11 security-focused projects, including a number of SSL implementations, for example, OpenSSL. And you'll see that, Firefox is in there. 1,400 developers, 8 responded. And in many cases, we had 1 or no response from the teams that we sent it to. So we sort of shopped the questionnaire around. We tested it on a team before we sent it out. We set up Amazon gift card raffle. We did what we knew how to do to get people to respond, but they didn't. So let's assume the questionnaire is bad, but there might be other things going on as well. So here's one of the banners from the project. How often do you engage in the following activities? One of the things we saw is that at least somebody mentioned every practice. And sort of up toward the top, just about everyone tracks vulnerabilities in some fashion. Everyone applies many people apply secure coding standards. By the way, the scale here, the sort of amber color is from not applicable to annual, less than annually, and then the aqua on this slide is monthly or more frequently than monthly. So tracking vulnerabilities and applying secure coding standards are common among the respondents. Now it was a very small group of respondents, about 30 out of almost 2,000 surveyed. So there's probably some kind of self-selection bias involved. These people would be more prone probably to answer positively about security concerns. But down at the bottom, how often do you engage in the following activities? Penetration testing is not so engaged in so frequently, nor is security training. And so this is a way to assess sort of where this particular population is. And the idea is that if you have this for your team or a group of teams, you can kind of see what's valued and what's not valued to the degree that people are willing to answer you. There's something called the unified theory of acceptance and use of technology that's been attempted in many hundreds of studies in information technology. The claims of which that, for example, performance expectancy, the idea that you think the practice or tool or technology will be useful is indicative of your intent to use it and then of your usage behavior, whether you'll use it more often or less. Similarly with effort expectancy, social influence, the idea is that if everyone else is doing it, you will probably do it too. It's sort of a measure of peer pressure and facilitating conditions. So if it was about the time of afternoon where you were a little bit tired, with the facilitating conditions here don't favor a nap, but they do favor maybe grabbing a Coke or a bottle of water. They're right in the back. So there are things you can do in terms of facilitating conditions in your development teams to enable, for example, tool use or review or the other practices you might apply. And so we extracted, now we didn't deal with the moderating factors down here, gender or age or experience or whether the usage of the thing is voluntary or not. Those are moderating factors. The 4 factors on the left, though, there's theoretical basis for believing that they help indicate usage behavior. So we built questions into the survey to address each of those things. And that's where research question 2 comes from. Does security practice adherence as measured by ease of use, effectiveness, training correlate with software development security practice use? 3 hypotheses, each of the metrics, whether it affects the frequency of use of the practices. Here are our survey answers for this practice is easy to use. People feel comfortable with documenting their technical stack, performing security review. Not so comfortable with applying threat modeling and performing penetration testing. This practice helps us. This is our effectiveness measure. We ask people to respond to, do you agree with the statement that this practice assists in preventing or removing vulnerabilities? Again, perform security review is high. People weren't fans of documentation. Publish the operations guide, or at least less so than the other practices. And I've been trained in the use of this practice. Again, we did a Likert scale here. You can come and advise me on better ways to measure this. But again, perform security review was at the high end, and people didn't feel like they'd been trained in, for example, applying data classification schemes. I wanted to pick on something. I also got nasty emails about the survey, as Dr. Carver did yesterday. Here's one of them. I'd remove security training. Classroom knowledge delivered via lecture is useless at best. Experiential knowledge and mentorship through hands-on experience is the only way to learn. Academics have trouble with this one, but it's true. Sorry. So this person may have been through a corporate training class at one point. And people will come from different perspectives. So the wording may be wrong, but I think you can get at the idea. So I think pretty much we would agree that training in some sense is useful. The vehicle by which it's delivered may matter. At this level, we're not exploring that. And here's sort of my summary. Training, as it turns out, apart from the comment just made, was always positively correlated. We did a linear regression for each practice between frequency of use and the 3 measures. Training was always positively correlated. The more training you had, the more frequently the practice was used. The story is more complicated for effectiveness and for ease of use. I'll start with the easier one. Effectiveness was on the extreme right-hand side of the scale. Was positive and often statistically significant. Sometimes it was negative, the idea that you do more, say, improving the development process or performing security training actually worsened usage on something. Maybe it's people like the guy who went through the corporate training class. And then ease of use was often negatively correlated with usage. And maybe the idea is that you don't like doing it, but you do it anyway for the case of security practices in software development. Although we really need more data before we can make claims like that. So these are the results. So our source lists were primarily focused, here's some limitations. Our source lists were focused toward large organizations, places like Microsoft and other large companies. Our practice list and vocabulary was developed by a small group, but primarily by myself with spot checking by several others. We had a very low survey response rate, maybe because our practice definitions are unfamiliar, maybe because our questions and instruments could use refinement. One person commented, your email states, the survey is anonymous and your responses cannot be associated with you, but then the survey asks for project names and GitHub URLs. They felt they could be de-anonymized from that, which in a small enough project may be the case, depending. So there are some challenges in surveying at the project level with these things. How often do you want to talk about such risky matters in these contexts? So, as a summary, we developed a list of core security software development practices. We surveyed 11 development teams. developed a list of adherence metrics, and our data training correlated with increased practice use. So here that is pictorially, and I will stop for questions now. Thank you. Yes.
You had an interesting group of standards organizations there, everything from HoTSoS, Sims, SafeCode, etc. Did you detect any bias in terms of their security practices based on whether it's open source versus a company that's oriented towards a product?
So the question is there a bias between the open source and the proprietary practice recommendations? I think if I phrase that properly. So here is sort of the data for that. Maybe we can just eyeball. I'd have to look and think about it. Offhand, like I said, each of them have their strengths and their focuses. Nothing strikes me in the looking and thinking I've done about it that distinguishes that. But the answer is there probably on the screen if anybody comes up with that right now.
Well, one example might be penetration testing. If I have a product, I may not want people to try to do a pen test on my products. I'd rather focus on standards or, that was kind of where I was going with my question.
Yes, so I do have an anecdotal story where we did a survey at a large proprietary vendor, and they didn't want the results of the survey released because it would give people an idea of their methods, they felt. And so I think that speaks to that observation. I think that's the case. That it may be that firms publish what they want you to know about their methods, not necessarily everything about their methods.
Where HoTSoS would be saying, look at everything.
That's right. That's right.
Other questions? Yeah.
What was the variation among the responsibilities of your respondents? I can see how certain aspects of this might be more the focus of a particular role within these development teams.
Yes, most of the people who responded were developers. I ought to have with me the slides for the breakdown between the roles. Primarily it was developers, so that the answers skew heavily toward how developers do apply these things.
Other questions? Thank you very much.
Thank you again.